Alright, so today we're going to cover radical functions. It's just a fancy way of saying square roots and beyond. Okay. So we'll start off with square roots. So you can say the square root of any number is the value that can be multiplied to itself. To give you your initial value. I guess you can say the initial value. Okay. So let's say, for example, if you have square root of 25. Okay, so we know 25 is just 5 times 5, or even 25 is negative 5 times negative 5. Okay, so square root of 25 is either positive or negative 5. Since if you multiply each of them to themselves, you'll end up with 25. Or in most cases, you'll just see plus or minus 5. Okay. You can actually do the same thing with 1. Square root of 1, we know that's just 1 is just 1 times 1, or 1 is just negative 1 times negative 1. Okay. Anything you can multiply to itself gives you 1 in both cases. So we know that square root of 1 is just positive or negative 1. Okay. So if we tried square root of 49. Okay. So we know that 49 is either 7 times 7 or negative 7 times negative 7. Okay. So that means square root of 49 can equal either positive or negative 7. Okay. Because each of them, if you multiply it to itself, it'll give you 49. All right. Any questions on that one? All right. I'll leave that up for a few seconds. Okay. Oh. All right. So now we're going to get into the, I guess you could say, the general idea. Okay. So let's just say if A represents a real number. Okay. Square root of A, what they call the principal square root. And if you have negative square root of a, of course, that's called the negative square root. Okay, and if you have the negative on the outside, negative square root of a is just like saying negative 1 times square root of a. Kind of like negative 4 is like saying negative 1 times 4. Same basic idea. Okay. Numbers like 1, 4, 9, 16, 25, 36, 49. Uh-oh, made my 9 a little bit crooked. 64, etc. Those are all perfect squares. Simply because 1 is 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, and keeps on going and going. So those are what they call perfect squares. So those are the one that if you have a square root of that number, then it'll just be a whole number. Well, an integer in some cases. Okay. Okay, so let's say you have some square root of a where a falls under the category of a perfect square. It's either 1, 4, 9, 16, 121, which is 11 times 11, any of those. Where a is a perfect square. Bless you.
Thank you.
Then the square root is a rational number. Okay. Not necessarily a whole number, because you'll see some circumstances where you'll have perfect square roots that end up being a fraction. But it's always a rational number. Now, if that square root of a is not a perfect square, so let's say you had square root of 3 or square root of 7 or square root of 12, then your answer would be an irrational number because you'd end up with a decimal number that really never ends. If a is not a perfect square, then square root of a is an irrational number. Okay, quick. For example, square root of 3. Okay, and last one for this particular section. If a is a negative number, then your answer is not the square root of that is not a real number. Actually, it would be a complex number, which we're going to get into either next class or the class after. Have to double check. So if a is a negative number, and the square root of a is not a real number. Okay, so for example, I'll bring that up a little bit. Let's say square root of negative 4. Now, if that would have been square root of 4, we know it's either 2 times 2 or negative 2 times negative 2. But with square root of negative 4, there's no number you can multiply to itself to give you negative 4. You can't do 2 and 2 because that would be positive 4. You can't do negative 2 and negative 2 because that would be positive 4. So that's why you wouldn't have a real answer here. We'll have a complex solution, which is later, but you won't have a real solution for this one. All right, so any questions so far? All right. I'll leave that up for a few seconds. All right. Okay, so let's say square root of, let's say A, is the exact same as if you have a 2 there. Okay. So if you don't see a value there, you automatically assume it's a 2. So really what you can look at it this way and say, okay, what number multiplied to itself twice will give you A? So if you have square root of 100, that's the same as having that 2 there at 100. So you can say what number multiplied to itself twice will give me 100, which of course is either positive or negative 10. And that number right up there is called the index. Uh-oh, sorry about that. Okay. And actually that index can keep going up. Okay. So if that index was a 3, we know if it's a 2, it's a square root. If it's a 3, it's the cube root of A. Okay, so if it's a 4, it's 4th root of A. Then it goes 5th root, 6th root, 7th root, etc. Okay, so it can go all the way down to whichever number you decide to pick, so we'll call that the nth root of A, where n can be any number you pick. Okay, so any questions so far? All right, so we're going to kind of make the association from square root and see how that relates to the rest of them. So let's say, for example, or not fine, but solve let's say for problem A, say the square root of 121. And let's say for problem B, say the cube root of 8. And let's say for problem C, the cube root of -8. So for problem A, the square root of 121 is really just asking what number multiplied to itself twice will give you 121. What number multiplied to itself twice gives you 121. And we figured that out earlier. It's positive or negative 11. 11 times 11 is 121. Negative 11 times negative 11 is 121. So the square root of 121, and it can be either with or without that 2 there. Uh-oh. Is either positive or negative 11. Okay. So now if we tried the cubic root, let's slide that up a little bit. Okay, so for B, the cube root of 8, just ask what number multiplied to itself 3 times will give you 8. So we know that 2 times 2 times 2 will give you 8. So that means the cube root of 8 is actually 2. So since 8 equals 2 times 2 times 2, uh-oh, don't need that there. That means the cube root of 8 equals 2. Let me go ahead and circle that one. Any questions on that so far? All right. And for C, we do the cube root of negative 8, which means what number multiplied to itself 3 times will give you negative 8. Multiplied 3 times will give negative 8. And in this case, it's negative 2, negative 2, and negative 2. Since negative 2 times negative 2 is 4, 4 times negative 2 is negative 8, we know that cube root of negative 8 equals negative 2. And that's since negative 8 equals negative 2 times negative 2 times negative 2. Uh-oh, that one looks a little bit odd there. Let me fix that up. Here we go. All right, so any questions on that one? Okay, so if you're looking for the number that will simplify this, you say, okay, what number do I multiply to itself 3 times to give you whatever is under that square root or root symbol? Okay, so this kind of shows a pattern. If you notice, we figured out that if it's negative under a square root, there's no real solution. But if it's negative under an odd number root, it's possibility there's a solution. So it actually is like that for all odd and even indexes, or indices as a plural of it's called. Oh, anyone's still writing? Okay. Excuse me. Yep. Okay, so in general, oh, bring that down some. let's say for nth root of some x value. If the index, and remember that n is your index, okay, if the index is an odd number, then negative roots, or a negative root function, can have a negative solution. Okay, we go right back to our cube root of -8 equals -2. Okay, so you can have a negative solution if that index is odd. Now, if it's even, you can't have a negative solution, or a negative real solution. So if the index is even, your solution, exists. That IFF, that's kind of a math if and only if. Seems kind of redundant, but it's something you'll see every here and there. Oh, where was I? Your solution exists if and only if the radicand is positive. And the number under the square root or the root sign, that's your radicand. Oh, close that up. All right, so let's say, for example, let's say if we wanted to find say for problem A, let's say square root of -16. Say for problem B, let's say the fifth root of -32. Let's say for problem C, the cube root of -27. Nope, actually that's supposed to be -16. Okay. So for A, there are no two numbers no number you can multiply to itself twice to give you -16. So square root of -16, remember that's an even index, is no solution, or no real solution. Okay. Now for the fifth root of -32, actually -2 times -2 times -2 times -2 times -2 equals -32. That means the fifth root of -32 is -2. Okay. Does that make sense? All right. Okay. So we do the same thing for -27. Well, the cube root of -27. Okay. So we know that Negative 27, you can make that equal negative 3 times negative 3 times negative 3. Okay, so that means the cube root of negative 27 is negative 3. All right, any questions on that one? All right. Okay, so let's say if you do a quick little explanation here. Okay, so let's say if you have, well, actually we'll save that one for the next one. I don't want to squeeze too much on this one page. Oh, anyone's still writing? All right. Looks like it's getting ready to shut off. Nice, well.